very intense set of slides in a short period of time, so bear with me. But of course, after this, we can always engage at different ways of communicating with Mtec, but I'm going to try to cover a lot of information, hoping that I can give you something different, something you haven't seen, and teach you a little bit and give you some information. It is about this 5.0 industry, but for me right now, call it growing your poultry business with IoT, data science, and AI. And so, first of all, why Mtec? I want to give you a couple of things about Mtec to get started. And we as a company have a mission. This is what keeps our company going. It's basically to lead a food revolution, which we're in right now, by supplying producers with the latest technology to help them improve animal welfare, increase yield and profit while sustainably feeding the growing world population. In simple words, this is the DNA of Mtec. We are driven by helping some of the people that are on the call, some of the producers really be better, more efficient, but we're very focused about animal welfare, taking care of really the animals. And so as a company, I thought I'd share with you that we are probably the industry choice when it comes to systems and platforms. Give you quickly KPIs. We're about 97% of all the US broilers and turkeys are running Mtec today. About 60 countries globally working with us, 10 out of the 10 largest producers, and about 65% of Latin America is running Mtec. So give you a bit of a sense of our market share. Simply quickly tell you some of our partners, and it's relevant to my presentation because without them, nothing that I'm going to show you today is capable of being delivered. This is the key to Mtec, is our partnership with some of the customers. You're very familiar, some of you, with some of them, and it's quite global. Companies in Australia, of course, the US, Brazil, Colombia, Philippines, Turkey, et cetera, et cetera. So quite a big market share. But I want to start this presentation by sharing that when you talk about artificial intelligence or when you talk about IoT, and I'm going to touch on, at the end of the line, this technology is not really powerful without the right people. Behind all these technologies, including the famous artificial intelligence with very advanced computing, there's people behind. And without the right people, you'll never be able to leverage this technology. So my underlying message today is people. At Mtec, we help feed the world by changing the way we farm. We do it. How do we do it? We develop the perfect platform to connect the entire supply chain. What do? We grow together with some of the customers you saw. We collaborate and we partner to deliver these platforms, and we grow our people. It all starts with empowering people, allowing people to have the ability to have innovation and have creativity to create these platforms. So refined data, that I consider the new gold. To me, it's like diamonds. By the way, I think as important, as powerful, and monetarily probably as similar to a diamond. So refined data, I mean good quality data, right? This you're going to see in my presentation. None of these technologies can be leveraged without good quality data. Don't misunderstand the point that having a lot of data, this big data, is not enough. It's got to be refined. It's got to be really massaged. It's got to be worked so that the computer systems can really process it correctly and build these algorithms that I'm going to explain today. So I start by that. Keep that in mind. Refined data is the new gold or the new diamond. So I thought I'd share quickly with you something I think is really interesting and puts things in perspective. In 60 seconds, watch how data has changed between 2019 and 2020. Let's talk about, for example, WhatsApp. Yeah, WhatsApp here on the top, 18.1 texts per minute. And in 1 year, we went to 19 million, 1 million more texts in the same period of time, but yeah, 1 year after. If you look at Facebook, one from 1.3 million. And you start looking around all these platforms, and it's mind-boggling. It really is crazy. 3.8 million to 4.1 million in Google. So the point on this slide is that the improvement of data and technology is exponential. So it's not that in 21, we're going to see the same growth. We're going to see an exponential growth. Now think about 2022 and 2023. So this is about reality. We can't stop it. It's inevitable. Things are moving at a speed that sometimes the human being cannot comprehend, including, of course, flying to space and many things you see with the big companies. So first, let's talk about the impact of this technology. The University of Tufts, which is based in Massachusetts, has said that for smart farming, so practicing smart farming can generate $2.3 trillion in cost savings, 2.3 trillion. Out of those 2.3, 250 billion come from artificial intelligence and data analytics. So basically what I'm saying is that the use of data science, IoT and artificial intelligence will be tools that some of our customers will use as secret weapons to grow faster. So those companies that adopt these technologies will for sure grow much faster, more efficient than those that don't adopt it. So I thought I'd share the Mtec technology stack, those that want to be or interested on the call. Mtec uses Microsoft AI. That is our platform. It is behind the scenes using Microsoft SQL Server. But to be more precise, we use these 6 technology stacks to run our company. I'm going to cheat a little bit here with my phone in terms of what they each mean. My team provided me, but let me share quickly what they mean. Azure ML, which is on the top left, is our core machine learning AI platform. We use this platform for our core algorithms. They're inside the Mtec software. So if, for example, rapid prototyping, rapid testing. So when we build new models, they go into the Azure ML. When the models get more complex, much more complex using neural networks, we use TensorFlow. It's another platform that allows us to build these algorithms, build this technology, but it's a little bit more faster and more advanced than Azure ML. Spark is where we do clusters. What clusters, in simple English, means is we combine multiple algorithms and build clusters of algorithms to deliver certain solutions. Python is our core development tool. Click is our BI, and RStudio is where we do data analysis and statistical analysis. This is this technology stack that Mtec uses today to deliver artificial intelligence to the poultry industry. Let's go now inside the Mtec Data Lab. I want to take you inside the Mtec Data Lab real quick, just so you see a sense of what we're working on. So I want to cover 3 things, the basic ones: IoT, data science, and artificial intelligence. So IoT, obviously a very, very important part of this journey. You must connect the farms, the hatcheries, the feed mills, and the processing plants. But it's a complicated journey. Anybody on this call that's involved in IoT would relate to this. But we must embark in the journey. IoT takes a lot of discipline, a lot of commitment, very clear plan. You must understand your goal. What is it that you're trying to adopt? And then you can deliver an IoT solution. I will show you a little bit more of IoT as I get deeper into the presentation. So when it comes to smart analysis or data analysis, I thought I'd show you how Mtec runs a project. When we get data, how do we convert that data into an artificial intelligence algorithm, a solution, a product, a software? We start by gathering the data. It's not easy. We've been doing it for 30 years. It takes time. Then comes a very important step, cleansing. Not only you got to get the data, you got to cleanse the data. You got to clean that data so it's prepared for the models to be trained. Then comes training the models. And here, training a model, there's many methodologies. You can take 70% of the data and use it as a training environment. Keep the 30% as a test to see if the computer learned what you taught the computer. But there's many, many other models on how we train the computer. Sometimes we use pieces of the data and keep some hidden to see if the computer can follow the patterns. So very important step is training the model. Then we test it, we evaluate it, and last but not least, we partner with a customer to see the effect in the industry, how well these models are working. So very important how Mtec delivers the full solution. I thought I'd share with you, why do we have this artificial intelligence now? Why is this so big right now? People talk about it. Why has it taken off? And how can we deliver now accurate projections? What has made us be able to deliver these accurate projections? And it's all about three things. First, data, 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 and data. I cannot stress how important the data is. But then comes the software and hardware advances. They have evolved in such a way that it's really powerful how fast we can deliver these technologies. And last, cloud computing. None of this can be done without the use of the cloud. It is how we leverage all these technology stacks in the industry. So how do you deliver AI? And I thought for you could be interesting that you see this basic graph. So what I'm saying here is that the traditional programming, old school programming, you have data, right? You develop code, you develop a software, and between the data and the software, it delivers reports, results. That's the old school development strategy. That's how you develop software. But when it comes to machine learning or AI, it's a little bit different. The data, still number one, but then we have the results. With the data and the results, we feed the data to the computer, and the computer builds the program or builds the algorithms. So it's really interesting how the methodology changes in how to do AI compared to traditional programming. Hence why we use all these technology stacks, all these different applications. They help us be much more powerful on how the algorithms are delivered. So the journey is all about connecting the houses, farms, hatcheries, feed mills, cleaning the data, cleansing that data. Keep in mind that, so you guys have an idea, in one broiler house, we can get about 5,000 data points in one day. Think about now the amount of data in a chicken company that can have 5,000 houses, 10,000 houses. Do the math. It's massive amounts of data points. Now, not all of them are clean, so we cleanse the data. Then we deliver artificial intelligence, right, to even smooth the data so that it's perfectly ready to deliver the algorithms. And then we go into achieving the planning. Now we start running these forecasts that actually provide us all the views. And then we deliver analytics, so UIs like business intelligence to show the results. This is kind of the journey for Mtec to deliver a full technology. So connect to the houses or the feed mills or the processing plants or the hatcheries, bring the data into a common hub, cleanse the data, deliver planning tools, algorithms, and then expose them on a business intelligence. So if we look at IoT, if we go inside the IoT world, we can see a little bit of what it means to Mtec and the industry. We're connecting houses by using sensors that can weigh birds, feed, temperature, humidity, water, and these sensors start bringing that data into the platform. But it's a very challenging environment. As we all know, we're dealing with farms. They're remote. Sometimes communication is challenging, maintenance of the equipment. So it takes a lot of discipline and a lot of work to get these technologies to work. Feed is probably one of the most important pieces of information. It's 70% of the cost of livestock. So we are using multiple technologies to feed, to weigh the feed on these bins that help us understand consumption. How much are these birds or pigs or different species are consuming, which we know it's very volatile, very different between farms, between breeds, between countries, and between seasons. These technologies are different. The one that you're looking right now, it's called bin truck, is load cells that go underneath the bin, suspending the bin, weighing the bin. But the one on the left, Bin Vision, is a temperature technology. We have temperature probes. It's a cable that goes in the middle of the bin. And between the different temperatures between what's full and what's empty, the algorithms can calculate the inventory. So it's a temperature algorithm allowing to measure the difference. This particular technology we call Feedcast or Littlebird. It's a magnet. They're outside of the bin and they make a noise. They hit the bin, and it's no different that if you take a glass, you put water, you wet your finger, and you go around the top of the glass, it makes a particular noise. But if you put more liquid, the noise changes. So this algorithm uses sound and noise to detect what's full and what's empty. What's really cool about this technology is we use a solar panel with magnets to control and weigh, so it's easy to install. We have apps, right? We now have applications on the phones that you see on the screen that actually provide all the data, the insight, the alarms, the graphs. It's quite interesting how we've delivered an application that's very intelligent, and we have thousands of growers in the United States and globally using this app to perform better on the farms. It starts understanding what's happening in the chicken houses or in the pig farms and react to it using artificial intelligence. Now let's talk about data science. And data science is a really exciting part of Mtec, and I think of any company that's creating this department. It's really about some really creative, very smart individuals that can build data and interpret data. This, by the way, could be one of the biggest concerns in the industry, meaning not having enough data scientists. I think it's going to be a deficit in many of our customers. Mtec tries to help with that gap. What you see on the screen is obviously the most impactful issue happening today, which is COVID. But I thought it was a good way to compare to what Mtec is doing. What you see on the left is variables, right? Age of the patient, cardiovascular disease, chloride, if it's diabetes, if it's a male or female, so the sex. All these variables can affect the mortality of COVID, right? The percent mortality, how many people are dying, what's affecting these individuals. And here you use data scientists and artificial intelligence to understand the impact. Let me explain. If we now focus on a 65-year-old female, yeah, what does it affect? What causes the most mortality on a female with particular attributes? And here's the explanation in a simple way. We have age, sex, body, the body mass, right? And then the blood pressure. So 4 variables: age, sex, blood pressure, and body mass. What the computer does is starts penalizing or rewarding those attributes that affect more the condition of mortality. What I'm saying is, if you're 65 years of age, it puts a ranking on you. If you have your blood pressure at a particular number, it gives you a reward. It means you are better, less chance of mortality. So it starts adding all these variables and comparing them and giving rewards and penalties to determine what the combination of these variables makes the most probable mortality. That's how data scientists work. That's how you use artificial intelligence. We apply this same model to chickens, identical. Now let's get to it. What are we doing? Well, we're working on models to predict bell curve. This is one of the most complicated parts of the chicken supply chain. Is what's the weight distribution in one given house? Now do it for every house. So Mtec uses artificial intelligence to build these bell curves. What you see on the screen is the accuracy of it. The little tips, the green and the little kind of orange is the error. The purple, Mtec hit accurately. So it's really impressive how accurate these curves are being fed to the system. And that's what really makes powerful this journey. This I thought was an interesting representation. Here we're trying to understand temperature. So Mtec is trying to predict temperature that's so important in the performance of the birds, or the pigs. So what you see here is that the green dots, the light green, call it lighter green, it's real data. It's the computer being trained. But the computer then drives and builds the darker green, so the blues. And so that's how it's forecasting what the temperature for next year will be at the same time today. And Mtec builds these algorithms. And this one, it's a regression algorithm that allows us to predict temperature in the future. Body weight. Quickly. So what you see here, every dot is a bird jumping on a scale, a bird scale. This is one day, one house. But Mtec starts building clusters. What means by cluster is that the data is consistent. This data seems to be the same. When a bird jumps in and the next bird jumps in, they seem to be on the same cluster. The rest is noise, and we clean it. Look at on the right side is the second pass. We now build a second cluster that we believe it's the right weight of those birds. It's a lot of data. It's a lot of work for one chicken house. I thought that I would bring feed quickly. So look at what the computer can do. Now we're trying to understand the relationship between starter feed and finisher feed. How much of each quality type of feed is the best quantity to reach the best weight? Here on the right is the weight of the bird. So if you understand this graph, basically what you're seeing is that if you give 1 pound of starter and you give about 4.5 pounds of finisher, give you your best weight. Now, that's easy on the graph to see, but it takes a lot of work with millions and millions of data points to really understand what's the best combination of the different formulas to feed the best to the birds. Now, here comes the other challenge. Depending on the bird size, these formulas and these ratios change drastically. This is feed consumption. What you see on the screen is that the red line is the computer created it automatically. The other lines are actual after the fact. So we fed the computer the data after the computer calculated it. So it says, I think this is the consumption. Then we overlay the actual, look how accurate it is. This is super important if we can detect consumption before it happens. Same thing here. This is condemnation. Everybody should know what that is on the call. When birds get to the processing plant and they're rejected. They're rejected because they have a condition. What if we can predict how many birds are going to be rejected at 14 days of age? We still got 30 to 35 days to fix the problem. So the computer said all the ones in blue are healthy houses. The ones in red are going to be with problems. Not yet. They're going to have a problem in the future. So we are predicting potential rejects at the processing plant. This can mean millions of dollars to a company. Millions. So last, let's talk about AI. And so the key to artificial intelligence in the chicken industry is more of a predictive mode. It's looking into the future, because in the past, we had in the poultry industry, including Mtec, we worked on a rear view mirror, reactive mode, which means when something happened, we're looking to the past and we're saying, what happened? Let's look at the history. And then why did it happen? Go back and look at the history. But now we want to go forward. We want to be able to predict very accurately, but most important is prescriptive. What if we can build the perfect recipe to grow a bird in Georgia, in Brazil, in Thailand, in Colombia, Medellin? So knowing all these variables, Mtec can build a prescription. It says, for that particular breed, for that particular house, this is how you should grow those birds. So this is super interesting. What I want to explain here is on the left side, we took all the data points. Think about just data. But if I feed the computer that data, as you can see, it's very clustered, it's very all together, and it doesn't tell the story. Our data scientists, these are people, not computers, have cleansed the data, have smoothed the data, have made the data be more logical. So this is what you see on screen, so that then the computer can start processing it better. If you don't have the right people in an organization, you cannot and you will not be able to leverage this technology. Either you use people internally or you partner with companies. And that's a very important message I'll leave towards my presentation. I'm running a little bit out of time because I know a given time, so I'm going to finish up, but I wanted to touch a couple more things. First, this is really cool. The computer in Mtec, our algorithms are creating columns, are creating more data points. Let me explain. On the left side is real data. So we have bird weights and temperature and humidity. But the computer needs to correlate more. It needs more data. So it starts creating data. Minimum temperature, maximum temperature, average temperature, difference temperature. So for one algorithm, we can create 600 more columns automatically so that we can correlate the data. So for 3 columns, we go to 600 columns, or from 6 columns to 600 automatically. This is called feature engineering, and it allows the analysis. A couple more slides here. We're using AI, training the models by using optical, and they can see the beak or the eye of the bird when it's infected, when it's sick, and when it's healthy. So with an optical view, we can really change the way we can use artificial intelligence. I thought this would be good to tell you real quick that, we got to be careful with the future, which is the last part of my presentation, as to where we're going with the future. Here you can see somebody going to buy a appliance and they're trying to sell, can I interest you in a firewall for your toaster? So it is kind of funny that AI is going to get really intense and it's going to be everywhere. So now you're going to need firewalls for your toaster because somebody can hack the toaster and burn the house, maybe, who knows? So funny, but not so funny. So to end, I wanted to cover just a couple more points in the future of technology. Here we're looking at cameras. Mtec is already using cameras. This one is called OptiFlock, so that we can understand the behavior of the bird. So it's not about video, but it's about interpreting the video and turning it into data. Here we can see 4 houses, and this is the life of the bird. And the line shows you when a bird is healthy or not in terms of welfare. So you can see that for the first 3 days, they were well taken care of, but as the days go by, their welfare conditions are deteriorating. It's the video that's interpreting this data using AI. So to finish, final thoughts. Quality of data is key. You gotta have good data. When you get into IoT projects, make sure you plan for quick wins. Make sure you have a clear strategy when it comes to IoT. And when it comes to artificial intelligence, set the expectations. It is overwhelming what AI can do. So you must set your goals and expectations. And to end, I thought this was really interesting. I read this in a Fortune 500 company. A year spent in artificial intelligence is enough to make one believe in God. It is that powerful, AI. So really, I'm done. I'm finished with my super quick presentation, but I wanted to leave the audience with the chance to come and join more with Mtec. So there's many ways we can help companies achieve your goals. Here you can see a link, which will be shared with you on the chat of this presentation. And you can download a PDF that gives you a little bit of what I shared today, and you can kind of explore more, or you can use this code. Either way, thank you very much for the opportunity. It was quite fast, and hopefully you got a little bit of what we're doing here at Mtec.
Thank you, Simon. As always, it's an excellent presentation, exactly what we were expecting, and actually, you actually were beyond what we were thinking to include. And we already have some questions here. So then let's go. Comparing to a standard dark house with basic automation like feed, water, environmental control, how much or more expensive will be to have a house, a broiler house actually, equipped with sensors and automation needed for data collection? And is it possible to estimate a payback in years for this investment? Do you think, I mean, since you have that experience with those projects, could you make a rough estimate of what is going to be the investment and how they will see the rate of return?
A good question and interesting, because IoT is super important. And yes, I can help. We at Mtec have been working very hard on that particular point, on making the equipment feasible, acceptable for the grower and the integrator. That's another important thing. Who pays for the equipment, right? You have a grower, a farmer, and then you have the company that processes the birds. Sometimes there's an opportunity to share the investment. Now, an investment of sensors can vary. Well, I'm going to give you an idea. Now, remember that also depends on what sensors you're using. And like you said, it depends also how that farm has been kept. If it's a newer farm, if it's an older farm. But I want you to think about investments that can vary between $2,000 US to approximately potentially 6,000, somewhere around the neighborhood. So you're talking about low-end sensoring to high-end sensoring. So you have a lot of room onto what you want to invest. But somewhere around those two is a typical investment of hardware. Then you got the software component, keep in mind. then most companies will present a monthly type fee or a recurring fee, software fee. So you got the hardware and the software to start with. Now let's talk about the payback. The payback is interesting because we've done some serious research and we've seen growers, farms pay this investment in less than 1 year. 1 year, which means about 5 to 6 flocks, you have paid your investment. The rest is all profits and benefits. So to answer your question, very feasible. To me, it's a matter of when, not if, companies will adopt IoT in their farms. Everybody will. It's a matter of time.
Since I know your company and your experience on this, I would like to add one question. You mentioned things details with live production, but in fact, you have a lot of experience with the whole chain, and you do work with the breeders, with the hatcheries, and especially also in the processing plants. And that is an area that we had not touched. Even you have a slide there related with probably image analysis of quality of carcasses and all the type of data that you collect in processing plants. You have a long history in processing plants with sensors and planning of the processing plant processes and all that. Could you mention a little bit of the parameters that normally you have been using that these companies around the world have, and how you help them with you have helped always with the capturing? I remember that from the times that we saw the whole evolution with going from pound, I remember that a lot of readers in pound, and now you have sensors that are on the internet directly sharing that information. So nowadays, for example, in a company in the US, and if you are going to compare, you have several clients in Latin America with probably lower technology on the processing plant. What are the differences? What are the parameters? And what type of data you receive and what type of data you help them to produce and analyze?
Yeah, so good question. So first I want to share or cover with you what's so important, Edgar, and you're right, is that it's not just farms. When we talk about hatcheries, for example, anybody on this call appreciates that if you take care of a chick's process in a hatchery, if that chick comes out of that hatchery in better shape, the performance in the farm is exponentially better. So hatcheries are a place that many companies care for, but you don't have a lot of data. It becomes an island. So we are connecting to hatcheries and we're getting amounts of data that's incredible. For example, not just the temperature and the humidity, we all know that, but it's the track of the egg. Where has that egg gone from the egg room all the way to the machine? And when the egg is being rotated and moved, every movement of that egg is now tracked with IoT. So now think about correlating that to a breed, to a performance on feed conversion. And so hatcheries, Edgar, are super critical to connect. When it comes to processing plant, I could spend an hour just on the plant because the amount of data that comes from a plant is massive. But to your point, on spot, this is a journey of the supply chain. It's not just a farm. You must connect all the steps of the supply chain to deliver improvements. Super important. When it comes to countries, Edgar, interesting enough that don't think that only the United States is ahead in terms of IoT. It's not. You got third world countries, not even third world countries, Latin countries, and even in Southeast Asia that are pushing very hard how quickly they're connecting to houses, because you don't need 100% internet. There are other ways to connect these farms or these areas. And so I see tremendous movement in Latin America, Brazil, for example, Colombia is pushing hard to try to connect faster. We're working with several companies in Colombia, for example, but I think the world is moving quite fast in this journey, for sure.
Okay, so we have another question here. We said that probably at 2:45 we will continue with Ruben. And the other question was, what about image technology for capturing? You mentioned some bird behaviors, and also you mentioned or showed a little bit about capturing weight of birds. Is this technology as accurate and reliable as the scales, or how do they perform, or do they perform together? Is any kind of combination, or you are actually doing some data with just the images?
No, that's a good one. And of course, I'm going to try to open up as much as I can. This is super important to Mtec, and it's in a laboratory. I'm a firm believer, and I really believe that optical cameras will be the future of all sensors. But it's time. We must let the time pass. And you don't wait till then. You must embark into the journey. But let's talk about cameras. Mtec is working with a couple of universities in the United States precisely on image and predict weight. I want to share one interesting thought. We now have cameras. There are different angles of the house. So they come from the top, but also they can come at bird view, a bird side, bird level. What we're measuring, for example, one of our techniques is we're measuring the leg, one part of the bird leg through the life of the bird. So we're imaging at all times the same group of birds. Remember, the chickens, they're very territorial. So as the part grows, we have algorithms that correlate to the size of the bird. So yes, the answer is 100% we're working on imaging to predict weight and of course behavior and of course welfare. Welfare and behavior are already running in farms at Mtec in the US, but it's the weight. Once we nail that, it's gonna be disruptive because then you don't need scales. So whoever asked the question, yes, I agree. And we are working very hard on optical to deliver plenty of data.
Okay. So the other is about the connectivity. Many farms are located in very remote areas, and maybe due to biosecurity and other factors, sometimes there are difficulties with connectivity and wideband. So then how do you do to link up those farms that are difficult to reach? How do you do that? Do you have any kind of special internet lines or something like that?
Yeah, there is. We've become quite creative. You're right that this is a big challenge. It's an underlying challenge and it's a reality, including the United States. So everybody that thinks, oh no, the United States is wonderful, they have the best technology. No, it's actually sometimes the opposite because our infrastructure, it's a bit outdated in the US. But Edgar, the answer is this: you got to have a hybrid solution. You got to have multiple options to be able to deliver the best design. So what we do is we come with a hybrid option, which means internet, great. No, it's not good. Then we go into satellite. We use cell phone. We use many different technologies, and some are coming new into the industry to be able to deliver that flexible option, Edgar. The other one is to reduce the packets of information they're moving around so that you don't need big bandwidth. You need very small bandwidth because you're moving little data points all the time, every 5 minutes, every 3 minutes. So you increase the frequency of the movement of the data, reducing the package of data, less bandwidth. The answer is yes, we're working with multiple. Satellite is one that's taken off right now because the prices are come down. Satellite is powerful for those countries and terrains that are complicated. So we have plenty of options to connect. This is what we do for a living at Mtec now. We basically have an entire division focused only on communication. So you have an idea.
Perfect, Simon. Thank you very much. And just due to the time, we will continue with Ruben, but if you can probably join us at the end of the talk, we'll try to do a panel. We also have here, you can see here on the bottom, we have Kevin Puckner. He's not going to be talking today, but he's actually representing JUMP, and he's going to join us for a talk next week. Welcome, Kevin, and then we will continue now with Ruben Vargas. If you want to start sharing your screen, Ruben. Ruben is a chemical engineer and a data scientist. He is from Colombia, and he works for Asymmetrics. Asymmetrics is a company dedicated to data collection and data analytics. It's part of a big agricultural group in Colombia that is involved in many areas, in feed additives and many others. Is part of, they call it the Illumina, that's right? Illumina? Did I say that? Illuma, sorry. Illuma, and includes companies like Premex, and they are involved with with other big integrators in Colombia, and they do many other things. And additionally to his experience, he is the leader of data science in this company. He is joining us today from Bucaramanga, Colombia. And he's going to be talking, the title of the talk will be From Pictures to Movies, Use of the Internet of Animals and Analytics for Value Generation in the Swine and Poultry Industry. So this will be the technical approach. We already reviewed the presentation with Ruben, and he had an excellent material related with all the data analytics that they are using on their side to capture data. They also have sensors and equipment for scales, for machine vision, and he's gonna show all about that. So you are ready, Ruben, all yours.
Thank you. Hello, everyone. This is a presentation by Asymmetrics, and I want to start by thanking Professor Edgar Oviedo for the invitation to make this presentation today. As he said, my name is Ruben Vargas. I work as lead data scientist at Asymmetrics. My experience is in data-driven decision-making, and my expertise is in time series analysis, optimization, and business intelligence. Sorry. Well, in the production of animal protein for human consumption, there are a lot of inefficiencies. And this is precisely our purpose, to make inefficiencies optional. We are addressing this purpose through an alliance with Edgar just mentioned called Illuma. And one of our partners in this alliance is Allura. This is a presentation. This presentation is connected to the presentation made 2 weeks ago by Allura's director for US Pork, Rian Van Dyke. We reduce inefficiencies by applying knowledge on data. Well, what kind of knowledge? Mechatronics engineering, AI, IoT, UX, data science, and in the core of all of this, animal science. And we have been doing this since 2009. Today, I am going to talk to you about our approach from pictures to movies. And this presentation is focused on the technical approach on analytics. Let's talk about the type of analytics. You have probably seen this kind of a slide before, but we want to talk about this. The analytic cascade is usually, and we recommend to follow it by steps. The first step is descriptive analytics, and is made when you are addressing a problem or a task through this approach, and you are usually answering questions like what happened. And when you do that, you are making stats, descriptive stats, tables, plots, and you are watching a dashboards. And we recommend to start through this stage because you don't want to be addressing a problem that could have been solved just watching at a dashboard using prescriptive analytics. And going through the cascade, you can answer questions like why did it happen and what might happen. And at the end, you could be answering questions like what should we do? And when we do that, we are using tools like optimization, and we are making recommendations. And as we move forward through the cascade, the difficulty increases, but also the value generation. At Asymmetrics, we do all of the approaches in the analytic cascade. To increase accuracy, we need to increase complexity. We can work with linear regressions and decision trees when we don't need very high accuracy. But when we need superior accuracy, we might have to increase complexity. Here's when models such as ensembles like XGBoost and deep learning come into the scene. Keep in mind that as you increase complexity, you might be sacrificing explainability. This is why linear regressions and decision trees are commonly used for diagnostic analytics, while ensembles and deep neural networks are usually used for predictive tasks. And I want to put like an asterisk here because And recently there have been like breakthroughs in this approach. And we are opening these kind of models like ensemble learning and deep neural networks, which used to be called black box models. And right now, the box is mainly starting to open. So we are being able to extract explanations and answer the why question with neural networks even. In this presentation, I will not be covering applications of linear regression and decision trees. I think you might have seen several of them through previous presentations and also in your course. Instead, I will be focusing on ensembles and neural networks. Well, we work in all of these approaches. To start with the justification of using ensemble learning and deep neural networks, I will first start to speak about how to evaluate machine learning models. Here we have a polynomial regression example. In machine learning, as in this polynomial regression, we have parameters. Actually, they are usually called hyperparameters, like the number of features, the polynomial degree, the max depth in decision trees, and the number of neurons or layers in a neural network. These kind of parameters control what is called the complexity of the model. With enough complexity, it might be possible to fit our predictions to virtually any data set, including noise. This is called overfitting. You can see that on the figure on the right. And you can notice it. Yeah, it is very clear on that plot. Well, what is the cost of overfitting? Basically, lack of generalization. It works on the data we have collected so far. You can see that the fit is very good, but it won't help us with new data. This is a serious issue, and this is one of the hardest tasks in machine learning, because we might want to take decisions based on this analysis to affect the future. And the future is precisely about new data. How can we evaluate the lack of generalization? One method to do just this is cross-validation. On its simpler form, it splits our dataset in two parts. We can call the bigger of these two parts training set, while the smaller will be the test set. As its name says, we will do the training operations on the training set. On the other hand, we will use the test set to evaluate our model capability to generalize to new data. And this is how we can get to plots such as this. As we increase model complexity, you can see that the training error usually decreases. This is our model gets very good at predicting the variables that it has seen, the data it has seen. At some level of complexity, which is the dashed red line, our model will start to mimic the data in the training set. This is called overfitting. The issue is that learning this level of detail will not be useful for predicting data never seen by our model, like the test set. At this moment, while the training error continues to decrease, the test error will start to increase. The goal is to find the model with the lowest generalization error. Is this the same as test error? Well, not necessarily. Fine-tuning the complexity of our model to obtain the minimum test error can be thought as a form of training. Therefore, we could end up overfitting to the testing set. And this is what the validation set is made for. Instead of splitting our data in two sets, now we will split it in three. Basically, we train our model in the training set, we fine-tune the complexity to obtain the lowest validation error, and finally, we test the generalization error in the test set. Now, let's talk about ensemble learning. What is ensemble learning? Basically, it is the aggregation of several models to obtain a single prediction. Let's go through an example. The first popular ensemble method widely applied was the random forest. It starts from the decision tree, which you have seen before. And there are several, well, the decision tree is very good at the explanation, but there are several issues with this kind of models. One of them is that it usually overfits to the training set. And basically, there is one parameter that controls this kind of overfit, which is the tree dip. But with very low dip, it will be harder to learn from the data. But as you increase, it will get very easy to overfit. Random forest addresses this problem by first training several independent decision trees. This is why this is called a forest. Independent because they are trained on random subsets of features and a random subset of observations. Second, we obtain a prediction from each individual tree. And third, we aggregate the predictions. In the case we are training a classifier, the aggregation would be a voting. And if we are training a regressor, one kind of aggregation could be the averaging. Random forest is an example with decision trees of an ensemble method called bagging. As random forest with decision trees, bagging trains independent predictors and aggregates the final result. Random forest was the go-to method for several years. Basically, after linear regression and polynomial regression, the support vector machine disrupted all of these methods, and random forest disrupted the supported vector machine. But right now, it is not the go-to method any longer. There is another kind of method for classical machine learning with basically overperform random forest, and it's based on another ensemble technique, which is called boosting. Boosting, on the other hand, starts by first training a weak predictor. With a decision tree, this will be a tree with very low depth. So the kind of inference that it can make is very limited. So we will start with very high bias and low variance because this is a model with very low complexity. And then we will start training sequential models to train on the error on the previous model. So it is basically all of the contrary to the bagging, because at bagging we have independent models, and here we have models which are completely correlated. Well, an example of this kind of models is called XGBoost. You might have heard about this, and this is the model which, when using classical machine learning, is basically winning all of the competences for predicting. Well, as we move forward into more complex models, like this kind of models, we start sacrificing explainability. So we won't be able to make the same kind of explanations like what we do with linear regressions with coefficients, and the explanations we can make, which are very simple with decision trees. But with ensemble learning based on decision trees like XGBoost and random forest, we can still rescue some useful explanations. Remember that a forest is based on a collection of trees. And on each tree, you can see that on the circle, we can inspect all of the splits. And on each split, we have a feature variable. And we can see how much the data set is splitted on the target based on this feature. Therefore, we can manage to average and quantify how important is that feature for a single tree. And then we can go back and quantify how important is that feature for the whole forest. And this is an example of this kind of explanation called, usually called feature importance. And this explanation is in farrowing. Here we are ranking the importance of each feature on the winning weight as a target variable. From the bar plot, we can say that in this analysis, the most important feature was the winnett per sub. followed by sow feed intake during lactation. And you can see that it is very useful to rank and prioritize groups of variables and also to discard features. But it does not say much about the kind of direction of the correlations that we are very useful to see in linear regressions. And this is a limitation. It's time to speak about deep learning. I will start by explaining the simplest of the neural networks, a perceptron. The perceptron is basically composed by two sequential calculation steps. First, a linear combination, which is on the green circle, and it's not different from an ordinary linear regression. But second, an activation function, which is the pink square. And this activation function is a nonlinear function. And as its name says, it brings the capability to model nonlinear behavior. If we were to choose a linear activation function, the perceptron will not differ from an ordinary linear regression. A deep neural network consists on an input layer, which are basically the features, and several layers of multiple perceptrons. And finally, an output layer to calculate the target, which is our prediction. There are several difficulties for dealing with deep neural networks. First, they are harder to train. They are not as easy to train as a linear regression or on our decision tree, a support vector machine, or even an ensemble learning technique like XGBoost. And on the other hand, they require a lot of computational resources. But there are some key advantages. I want to mention two. First, feature extraction. With traditional machine learning, like XGBoost or random forest, there is need for human intervention to start making sense of data. This starts from the extraction of features from the raw data, which we expect to help us explain the target variable. Using deep learning and enough data, we can leave the feature extraction task to the machine. On the other hand, as the amount of data increases, there is a point where deep neural networks tend to outperform all of the other machine learning alternatives. So when we have such an amount of data, basically deep learning will be the kind of models with the highest performance. This is an example of technology. I just saw that you asked about that. We have this technology called peak vision. And with peak vision, we are able to track finisher growth on a daily basis. With enough data, in this case pictures, the deep neural network is able to extract the features and accurately predict the weight of the peak. Let's talk a little about time series analysis. This is another technology by Asymmetrics called Smart Weight. With Smart Weight, we are able to track the growth of the chickens on a daily basis. In this first plot, we have the average weight of the chickens on a black line and the barn temperature on the orange line. It appears to be a negative correlation between both trends. If we calculate a Pearson correlation coefficient, we will surely notice a strong negative correlation. Does this mean that decreasing the temperature we will get more weight? Well, let's look at another plot from the same flock. Here, the black line is the relative weight gain. This time, it appears we have a positive correlation. And does this mean that increasing temperature, we will get more weight? Which of these is the right approach? The answer is neither. Here, we have another variable, the age, which is correlated both to temperature and growth. Through age, broilers grow with relative weight gain as relative weight gain decreases. On the other hand, as they get older, we reduce the temperature in the house. And this is very common when looking for correlations in time series, and is usually called an spurious correlation. And if we are trying to find correlations in time series just like that, start by making time series stationary. How? Well, you can do differencing or detrending. Differencing is basically taking the change from one data point to the data point previous before, or you can do that several times until there is no change in the trend of the whole time series. And the trending is like fitting a regression between all of the variations of the time series, and then just taking the difference of each single point from the regression, basically the residuals. And we will end with time series forecasting. Dealing with forecasting, we are trying to predict the future. In the past, we were just analyzing to trying to find any correlations, but here we are no longer doing that. We are trying to forecast what will happen next. There are classical approaches for such tasks, such as ARIMA and state space models, but currently best performance is found with Bayesian statistics, recurrent neural networks, and other machine learning models. Usually this is taken it is used very often right now, and is to transform the time series forecasting task into a machine learning task. But I will explain more on recurrent neural networks. Recurrent neural networks are a kind of deep neural networks mainly used for time series forecasting. Well, why deep neural networks? With enough data, I mentioned before, deep neural networks, and in this case, recurrent neural networks, will tend to outperform the other methods. So if we have enough data, basically it can be one of the methods that is most recommended for the task. On the right part of the slide, we have diagrams of the basic units of two kinds of RNNs. The first is from a simple RNN unit, while the second is a more complex RNN unit called LSTM. I won't explain the detail of each element, because what I want to transmit is what these units are good for. There are two key concepts here. The first is from the simple RNN unit. This concept is called autoregression, which is to use the information from the nearest past to predict the future, the immediate future. And this is what the RNN unit is good for. But for some tasks, when you want to predict the future, the information from the nearest past is not enough. And this is what the LSTM was made for. LSTM stands for long short-term memory. And as the name implies, they were built to include memory capabilities in our neural network. We can think on memory as the use of information not necessarily recent to predict the future. So when we want to include this kind of information, we move into LSTMs. LSTMs basically decide what information to keep and what to forget. What do we use forecast for? At Asymmetrics, we make time series forecasting with peak vision and smart weight to predict the weight of the animals in the future. We can use this estimate when we can use this to estimate when will the animals meet the target weight. And this is all. Thank you very much for your time. I am open to your questions.
Thank you, Ruben. Excellent presentation. You include all the topics that we wanted, and many of you will be surprised with the amount of information on new technologies, but in fact, you will see all that in this course. We already have this material prepared. You have some examples, some exercises, and you will find out that these techniques are relatively simple to do. There are software that do big part, but that will be probably the first question where I'll receive more questions from the public. The first question for Ruben is that you explained to us a little bit, and when we chat a couple of times, for this presentation. You mentioned the software tools that you are using. Could you tell us what you are using for all these, and how do you create from the data management all the way through probably the delivery of the results? How do you manage that with different software?
Well, to train to manage operations with data, our main framework, we use Python. For training models, for classic machine learning algorithms, we use scikit-learn. And for neural networks, we use several kind of packages, but mainly TensorFlow and Keras.
Mm-hmm. So, and you mentioned that big part of, in general, the R language is what you manage most of the time, that's right? And
the what? Can you repeat?
Python, and you mentioned also R sometimes?
R?
Yes.
We use R for statistical analysis, for classical statistical analysis. We still use that, but much of our team is currently using Python.
Python, okay, very good. This is related with imaging. So somebody wants to know if with X-ray scan, I don't know if you have worked with that part, you can actually predict a skeleton structure of broilers, layers, and swine, and to know the responses that they may have in a diet. I know that your group also is in the mineral side. I don't know if you have ever explored that area of scanning an animal with X-rays.
As far as I know, we haven't. There are several tasks that are being addressed with convolutional neural networks. So maybe someone is working around that, but we are currently not.
Okay.
In our case, and sorry, I'm not on the video anymore, but in our case, Edgar and the participants, you know, X-ray, we're definitely very big into 3D imaging right now. No, a little bit different, but to be somewhere similar, the X-ray, what's very common to us right now and very powerful, and we're still working on our R&D department, which, by the way, for Mtec is based in Israel. We're doing a lot of 3D imaging, Edgar.
Yeah, I was ready to mention that I knew that you were doing something like that, because of that I include the question. But Carrie Walk, she's asking to Ruben, so that first saying that it was a very informative presentation, and there is a minimum amount of data or variables that can be analyzed using random forests or neural networks. I think that this is a very important question, because sometimes people tend to overdo and do analysis. If they think that they have 300 lines, they can do a random forest or a neural network that will be meaningful. Sometimes for an example is good, but sometimes it's important to have more data. So could you tell us a little bit about what will be, how do you work on that, on the volume of data that you need for those two techniques? I think that you're muted, your microphone. Ruben, we cannot hear you.
Okay, yeah.
Okay.
This is actually a very good question. And this is, it is not a black and white answer. So it is not a clear number of data that you can use for, but I will answer through this plot. It's not this one. And if we are using a complex model like the one you mentioned, with a small amount of data, it is very easy for the model to overfit to that amount of data. So this is basically the problem. When we try, well, at the moment we try to generalize from this model, it will get hard. So how can you detect that this is happening with the amount of data that you have? Basically, one way is to look at the test error. And if you have such a little amount of data, it will get very hard for your model to have for a complex model to have a good test error, or a test error which is similar enough to the training error. And on the other hand, if you have a small amount of data, depending on the task you are trying to do, it is highly recommendable to go to simpler kind of models. And for this, if the simpler models are not accurate enough or doesn't have the performance you have, you can always go into more features, or in the other hand, to more observations. This is increasing the amount of data. And as it was mentioned before, this is why data here and clean data is like gold, because this is the raw material for complex models.
So in the next weeks, you are going to have some modules that will start evaluating this, and you will be able to estimate the test error. And as you will see, at least in JAMP, it takes just a few minutes. Just that the JAMP, it has some tools that are fixed. There are things that they decided, and as the default for JAMP. In other software that you, or other language, you can program how you want to do this test and how you want to, what type of neural network you want to use. Like they are using this RNN. So then depending on that, you will have more flexibility when you use other languages. But you will learn these things about training error, testing error. That is part of the exercises and the outputs. You will be able to see it. And there are things that are calculated, and you, depending on the type of data that you have, you will be able to do it and know if the data that you have is enough or not. But definitely, most of the little things that we do sometimes in experiments, especially if they are controlled, probably they can be overfitted if you use a tool that is more advanced. And so another question, and this is, then we start a little bit the panel, because we only have like 12 minutes and still we need to make some announcements. And this goes for Mtec, but I also, I will leave you, because Asymmetrics also have a great experience. By the way, I have to thank Asymmetrics, because we have used their software, their hardware, and a little bit also of their analytics here at the university for some years. We have to say that we mentioned that the company is originally from Colombia, and Ruben is in Colombia, but actually the headquarters are here in North Carolina, because they are a North Carolinian company, and the CEO that is there, Juan Pedro, is listening to us. He is with here in Durham, North Carolina. So this question is for Simon, but what is the biggest, but both of you, because both of you also use poultry scales and have a lot of experience on doing those. And not only poultry, you also do estimations of weights for swine as well. So for both of you, what is the biggest challenge you have regarding the poultry scales? Are they solved? Are these issues solved related? For example, I will ask you about not only weighing chickens, but actually one challenge is to weigh the breeders. So Simon, if you want to start, and later Ruben can give us some insights on that part, and we still have time for one or question or two if somebody else from the public wants to send us questions.
No, that's a good one. And I appreciate the question. Edgar, you hear me okay, right? The voice is good, right? You. Excellent. So I'm very involved with this one. And so I have hands-on. I spend a lot of time in farms still today, and know that there's a lot of problems with bird scales. It's not that the hardware is good or bad. It's we're dealing with live animals. Simple. The biggest problem with bird scales, I'll start, is that the older, heavier the bird is, the less they get on the scale. As they get older, as they get heavier, they tend to be less interested in jumping first above ground, because the scale is just a little bit above ground. You still can have the ground scales, but they're a little bit higher. So the birds don't want to jump and they don't want to move. So you lose data. So from maybe having thousands of data points, when a bird reaches about over 28 days, you start seeing maybe hundreds of data points. So exponentially less data. Number two is a sample of the population. On a typical chicken house, let's focus on poultry first. You got probably 30,000 birds on an average. How many birds jump on the scale represents still a very small percent of the sample. So the answer is many, many problems still with bird scales. That's why during this session, we talked about it. Optical, cameras, and other technologies will be more important than the bird scales. The algorithms, the technology that both companies, Asymmetrics and Mtec, presented today, also need to overcome the bad quality data we get from the hardware. So we would rely more on the data, less on the hardware. So that's kind of my quick one on that.
Ruben?
Well, I basically agree with Simon. As they get older, we don't capture much information, and there is an issue with that, and is that lighter birds get weighted more than the heavier. So this is a problem for the system. There are also several issues like the behavior of the animals and, well, what happens with the materials with the system, but it is a hard task. And we were moving forward working around that.
I'm getting another question here for with my chat here. They are asking, what about for swine? So what are the challenges with this big vision and the differences in between genetic lines? So the shape of the animal probably and the body composition makes them that they will be having a little difference on the body weight. So have you captured some of that variation? How do you deal with that?
Yeah, I mean, we're working on the pigs is definitely super challenging. You know, that mechanical technology scales and stuff like that just didn't cover. So we're working hard on the 3D optical and the 3D hands, precisely the body mass, the shape, genetics differences. And keep in mind that in the pigs, most of you know, not only you have your core genetics, the PICs of the world, but you also then have variations within large operations that have their own genetic nucleus. So how do we deal with it? We're dealing with it with the 3D imagery, but also very much more data. And so the thing about it is taking the data much more wider. So not only about that animal composition, but the feeding is so important, the nutrition, and also tracking the genetics, being able to follow that genetics through the line, I think are the methodologies we're going after accuracy on pig weighing.
Any comments, Ruben?
Yeah, well, for us, actually, the pig vision experience is highly interesting. We have a camera deployed in production right now. We captures the weight of the animals with an error no higher than 4%. We are using this camera for making the harvest of the pigs, for detecting moments at the growth where the animals are not matching or not following the standard or the growth you expect from them. We are also using the camera to find correlations with another environmental variables that we track through sensors. And this is one of our cores and one of the technologies we feel very proud about.
Okay, very good. So we are in the last minutes of the webinar. I thank you both for your participation. Excellent talks. As really that covers pretty much our expectations for this. I also want to mention that most of the speakers want to have contact with you. So if I think that Federico had already posted that request, if somebody doesn't want to be known by the others. And also we want more networking, not only with the speakers, but also among you. So you are participating in a course if you were coming here in Raleigh. So we will have nice dinners and nice wine. And consequently, you will have a good friendship with all these people that are interested in this area. So since we cannot have that, then we will have the virtual thing, so the virtual internet. sometimes those relations are difficult to find, but sometimes they last long. So we will try to share all these contacts with Simon, with Ruben, and all the other speakers that we had. And among you will start, you actually have access to contact any of the other participants in the forum. We try to centralize that, and you can post and try to chat with them. But also I want to announce in 2 minutes here, by next week, you are going to have the calendar, because today we finish all the speakers that we had for the month of April. And in May, then we'll have Christopher Scott, that he will be coming from Tableau, and he's gonna show us how Tableau enables data-driven decision-making, visualization, especially on different aspects. They have animal examples. We gave them a couple of databases that they can play with a good number of data. We also have one person invited from DSM, that is the team leader for biostatistics and data management. And he will be talking about systematic data management to enable data mining across studies. Then we have Kevin Puckner, that you saw that entered a moment ago, and they have what they call these academic ambassadors. They are people that are either in academia. He works for a university in California. Christopher is actually from Raleigh, France. Is in Europe, I think that in Switzerland or Germany. And Kevin will be coming from California to us, and will be actually having this talk on building statistical models with missing data. So missing data is really something that we didn't include on the manuals, but it's something that happens, and actually there are software that can help you to solve that issue that is common, and actually there are techniques that are validated for that. And we have Alex Karigianis, that is a senior scientist in biostatistics in DSM, and he will present using the dashboard to monitor product development. Later, we are going to have a professor from Wageningen University in the Netherlands. He is Suresh Netirajan, and he is an expert. Probably you go to Google and search on pretty much sensors in poultry and in animals in general. He works even with zoos as well. So then he is an expert on sensing and how to analyze data coming from sensors, and different type of data, not only house data, but actually the ones that you can insert in the animals. And he will be using that big data in poultry and swine business. You can find out, and you already will have available several of his recent papers that are pretty interesting about all the things that you can do with sensors and how to use that data. So Kerry, that you have seen that she has presented, she has been present all this time. She is from the US, but I think that she is still in Europe, in the UK or in Switzerland, also working with DSM, and she will be presenting applying data analytics in innovation, an example of corn quality and fiber management. She has quite a lot of experience on enzyme development and research, and working with previous companies and now with DSM. And later we have from California as well, Dr. Maurice Piteski. He's a veterinarian, also passionate for all these things with sensors and data analytics. And he will tell us about the challenges when using machine learning in the poultry industry. So he will tell us what all his applications. He actually created a company that does some data analytics. It's a very interesting fellow that we had here in North Carolina several times. We do some contacts with him in the past, and I think that we will have an excellent program in the next month. Federico, any final announcements, or Camila or Gustavo, if you want to mention something? I think that we didn't have many questions for this week. You have some exercises to accomplish. The great majority have done it, but Federico, I'll let you talk for a couple of minutes.
Thank you, Edgar. No, basically for next week, we have a soft week for those that need to catch up with the content. There is one module basically explaining what is the data analytics program from NCSU, and one exercise and 2 new models. And with these, we are closing the first level of the course. So the new content that we will be launching afterwards, the two modules are already from level 2. What Edgar mentioned, we are now entering a new phase of the course. So coming to the exercises, to the practices, today is the last day for the first exercise that we have joined together from module 9 and 10. Next Friday, you will have the deadline for the exercise of module 13. And on Monday, we are also posting a new exercise for module 17, which will have, again, 2 weeks of deadline. So try to catch up with that. I have received a request from 2 people that are sick with COVID, so we will give some more days to them to finalize the exercises. We can be flexible in that sense, but try to please put the exams, your answers before the dates. The program that Edgar just mentioned and shared with you is already in the calendar of the course, so you can go back to the calendar to see these presentations and see who will be presenting that. And we will be sharing what Edgar just shared with you along the week. So we are on track. This week was a tough week for a lot of you. I know that you have catch-up. Congratulations for that, and keep the pace, because we can say that we're almost at the half of the course, Edgar, with all the material that we've been posting. So, so good for all the people that have done it on pace.
I just want to mention that a big part of this is a review of some statistical and analytical concepts that are necessary when you are going to especially apply this to industrial settings. But coming from the next part, we will have some experimentation that many of you, since you work in research, you are familiar with these basic experimental designs. But after that, we will go through the truly analytics what between Simon and Ruben explored today. You will see all of that. So that was the reason to have these talks today, because you will start seeing. And we have not done much with Tableau. That Tableau is a very simple way to handle data, visualize data. And you will see that after we get this talk next week, then we will start giving you some little exercises and things like that in order that you get familiar with more simple things, with data that you can actually take and just present in a very simple way. But the other analytics will be coming soon. Camila, Gustavo, you want to mention something?
No, I don't think so. We didn't receive like many questions this week, so everything is good. The questions that we received regard R and Jump were solved right now, so we are good.
Okay, thank you very much. We just moved 4 more minutes. We were a little bit behind in those minutes, but anyway, so thank you for your attention, and then have a nice weekend. We'll be checking the forum, and let us know if you need any help with the rest of the modules. Good afternoon. Bye-bye.
Thank you.
Thank you.
Thank you.
Thank you, Simon. Thank you, Ruben. Have a good week.